The main contributions of our paper are: a pure data-driven NPC is proposed to solve the fuel optimal control problem. A novel attention-based module NVFormer is designed to implicitly model the relationship between vehicle dynamics, road slope, fuel consumption, and control commands. Compared to the PCC baseline, our NPC framework saves 2.41% of fuel consumption in simulation testing and 3.45% in open road highway testing. The NPC consists of following parts: future data sampler, online past data sampler, primitives generation, NVFormer, and fuel saving optimizer. Both offline and online past data consist of vehicle information from the embedded equipment and altitude information from the HD map. The future data sampler generates velocity samples by the start point, anchor points, and endpoint. The S-value of each anchor point refers to the position of the local maximum or minimum of the altitude curvature. Velocity curves are sampled within the speed bound of each anchor point. The online past data sampler distills important samples from past data with used features and current freight trip. Firstly, sample primitives are sampled from online past data excluding the latest data sequence. Then, we generate inference primitive combined with the most recent data sequence, velocity curves from the future data sampler, and altitude from HD map. Then NVFormer receives the inference primitive and sample primitives, and generates future 3 km future sequence reflecting vehicle status. NVFormer was trained on real-world truck data with total length of over 20,000 km. The datasets cover various vehicles, routes, loads, and weather conditions. Compared to LSTM and Transformer, NVFormer fits vehicle parameters best. Finally, the fuel-saving optimizer calculates the cost for each future curve. The cost function balances velocity and fuel consumption. The future feature with lowest cost will be used to generate truck control commands. Closed-loop validation of NPC includes simulation and open road testing. The simulation, we select 15 about 10 km long scenarios with different slopes. For each scenario, we set 6 different values of target speed. And we conduct experiments with PCC baseline, NPC with LSTM, Transformer, and NVFormer. We interpolate the result to compare fuel consumption of these methods with the same average speed. NPC with NVFormer can save 2.41% fuel in our simulation. For open road highway testing, the testing site has a total length of 145 km and covers various terrains. We conduct experiments with PCC baseline and NPC with NVFormer. In open road highway testing, NPC with NVFormer saves 3.45% of fuel consumption compared to PCC baseline.